If you're anything like I was, it's on your bucket list to create a package for the Python package index. I'd been wanting to do it forever, but I'd always been too scared to because it was too hard, or I didn't think I was ready for it. And then I actually did it and it wasn't that hard at all. And I wanted to make this video to show you that it's not that hard to do it yourself. As long as you have a good idea and a way to do it, it's actually very easy to put something onto the Python package index and share it with the world. And maybe, who knows, your package will become the leading package in its field, or maybe you're breaching into, I'm calling it a new market as though anyone sells anything on this thing. But you're creating something new that no one's ever done on the Python package index before. I actually originally started this video in the code editor, and I finished it and I realized I actually should probably show you around the console first. So I'm going to do that, and then I'm going to go back into the past. Just the way these videos work sometimes. So this is the main console for the test Python package index. I used the test one. I didn't want to push a test package onto a live repository. This test one is a good one, or a good place to test your packages to make sure everything's working properly and to make sure everything looks okay. I would recommend using this first before you use the main one. But this is your main projects. As you can see, I've tested quite a few. Some of these actually came to fruition. Some of these did not. Actually, a number of these didn't really go anywhere. This is the one that I just finished making a video of. You have your organizations, you have your account settings in here, which is actually pretty useful. We're going to need to be doing something in here. You also have this publishing thing, which is just documentation by the looks of things. Okay, so we want to go into the account settings because I want to show you how to create a token first, because it's actually quite useful to have. Regardless of whether you're going to be uploading them in your own shell or whether you're going to be doing it in GitHub Actions. I'll talk about that in a future video. You're going to want to have a token. So you want to come down to where it says API tokens, and then you want to click Add API token. You want to give it a name. So we're going to do video. Permissions, upload packages, that's the only one you get. And then you have your scope. So you can choose to create a token for all projects, or you can choose to create a token for just an individual project. If you are wanting to create one for just an individual project, the project already needs to exist, so you need to have already pushed it once using your username and password. So do keep that in mind. That also means that you can't push the very first version using GitHub Actions or any other CI like that. So perhaps your all projects one is the better way to go, because then you can just create a new project using it. And you just need to create a token. And you have your token here. I'm not going to bother blowing this out because I'm going to delete this. But you need to copy the token and put it somewhere. It doesn't really matter where. But if you forget it, then that's it. This token is gone. It won't actually show you this token ever again. So do keep that in mind. It gives you some instructions, but I also talk about that a little bit more in here. And you can also, one thing I don't talk about, this might have been new, is that you can set your environment variables in this PyPI RC file. PyPI RC file, it's not PyPI because that gets confused with distribution. But you can put them in here like that, so you don't ever have to supply them with Twine. But we'll talk about that a little bit later. So now that we've created our API token, we now need to create the actual, all the files that needed to build and upload the package. So I'm going to go back to past me, and he'll explain everything you need to know. So I have this folder over to the side called Carburetor, and this is our package. And it's named after what's called the namespace. So it doesn't have to be exactly the same as the package name. So for example, discord.py uses Discord as the namespace, not discord.py. But this name is how you import it. So in this case, it would be, import Carburetor or import Carburetor CBR, or from Carburetor import this, that, and the other. In the same way that it would be, import NumPy or import pandas. The NumPy and pandas folders in those instances would be called NumPy and pandas. So make sure that the namespace is at least related to the package in some description. And then inside that, you need an init.py file or dunder-init.py file. So that's 2 underscores either side. And this is just here. It doesn't have to have anything in it, but it's just here to tell Python that this is a package and should be treated as such. In here, I just have a function. You can put functions in here, and it will just be, if you did from Carburetor import add, you'd be importing this function here. but you can do all sorts of stuff in the init. Over here we also have a dunder main. Now this is entirely optional, but this is more for like loading as a module using the CLI, and I'll show that off a little bit later. But you can just have something simple like this. A simple print statement with some lyrics to a song. I'm not really sure what it is. I've just kind of seen it around the internet a lot. So yeah, it's also worth noting that you can have a single file package by doing, in this case, carbo.py, and then you don't have to have a folder at all. But that's only really useful for small packages, ironically like this one, because it is just the one file to do it. But it will work exactly the same, which is kind of cool. So first things first, we need to let's create a README first. A README is always good to have, and this is actually useful to the tutorial. I should say also this is going to be kind of a lot of copy pasting just to keep the time down, but I will explain everything as we go. So I've just got some basic, README stuff in here. Some more lyrics. I keep seeing these around. I don't know where they're coming from. But yeah, this is a test package for a video tutorial. Just a little description as you would do your README. I'm sure everyone knows what they are. Next up, we are going to have our pyproject.toml file. macOS, come on, play with me here. And we're going to copy this and put that in here. So you can have other stuff in your pyproject.toml as well. This is mainly for like tool configurations. So if you had something like Black or ISort installed, then you could configure them in here. There are other ways, but I generally like to configure everything in pyproject.toml. If you use Poetry, you'll also be particularly familiar with this file. But in this case, we just want to have a build system that requires setup tools. And I'm not sure if greater than or equal to 42 is the best thing to have anymore. But I believe version 42 changed something. And I'm pretty sure this came straight from the PyPI documentation, but you can probably put a future version there, it'd be fine. And you need wheel as well. And this build backend, setup tools.build meta, it just tells the tool we're going to be using to build our Python package how to build it. You don't really need to understand what it does per se. But yeah, that is our pyproject.toml file. Next, I'm going to have our setup.py file, and this is where the vast majority of our time in this video is going to be spent. So there's quite a lot in here. We are going to type this one out. So first we're going to import pathlib, and we're also going to import setup tools, and then we're going to have setup tools.setup, and in here, as you can see from the tooltip there is quite a lot of things we can do, and I am going to be talking about quite a few of them because a lot of them are very useful. So we're going to start with the name, which is just the name of the package. Now I tend to put the name of the namespace here just to be kind of uniform, I suppose. Then you have the version. So in this case, it's just going to be version 0.1.0. You can put anything in there you like, so long as it conforms to PEP. Oh, I'm going to get this wrong on only 449, might be 459. I'll put it on screen. There is a PEP that defines version kind of schematics or version semantics that you have to follow. And if you don't follow those, then your package won't get accepted. So do make sure you look at that. Then you have your brief description, which is the one-line thing. Now I'll show you real quick. So analytics is one of my projects that I put on the Python package index, and the brief description is this bit here. So it's this kind of one-line introduction, and it also appears here as well. So I'm just going to put brief description for this, just so we can differentiate it from the long description. And the long description is, where is it? Here it is this bit down here. And this will generally be your README. So to do that, we can do pathlib.path readme.md.read text, and that will read that file and set it as the long description. However, because it's markdown, we do actually need to tell setup tools that it's markdown. So we can do a long description content type, and we can set this as text markdown. Obviously, if your README is in RST format, then you'll need to specify that. If it's in HTML format, you'll need to specify that, etc., etc. But mine is in markdown, so we do that. Next is the URL. And I will say at this point, it doesn't actually matter what order you do these things in. And a lot of them are optional. So these kind of 4 or 5 things at the top, these are sort of necessary. It won't shout at you if the description and long description aren't there, but you generally want them. Everything else is kind of optional from this point in, but generally very useful. So we have a URL. So this is kind of just, a URL for yourself. Generally speaking, a lot of the time, this is just the link to your source code, though I'm just going to use my website for example's sake. Then you have your author, so that'll be your author name. And then you have your author email, so this will be your author email address. So I'm going to use my business email address here. Any business inquiries, do feel free to get in touch. Then we have our license, and this isn't the full license, this is just the name of the license. So in this case, we're going to use the unlicensed, but you can put obviously any license you want in there. Next up is, we'll do the project URLs next. Project URLs, and these are these down here. So where it says project links, so where on mine I have the homepage, the bug tracker, changelog, CI, documentation, source. These are all set in here. So for example, you could have, I'm just going to actually copy paste this one. You can have something like this, where you have your documentation is this URL. This URL doesn't exist. I'm just putting it here for example's sake. And the source, you could have it something like this. Again, it might be the same as URL, but it's good to have it here. This also doesn't exist at the moment. I might put this on GitHub. I haven't decided yet. So watch this space. If you really want it on there, then leave a comment and I'll put it on there. But yeah, these will go, I keep going that way. These will go here. Next up, we have our classifiers. Now these are, if I just bring them up, are sort of like tags in a way. Oops. Oh, go away. There we go. I don't know what I was up with that. So these are tags. So you can have as many tags as you want. And they are basically like little things to say, well, they're descriptors, I guess. They tell the users what state your project is in, whether it's in planning or alpha or production. It tells you what environment they expect to use. It tells you what framework they're in, intended audience, license, natural language, operating system, programming languages, topics, all sorts. It tells you a lot of stuff. And as I said, you can have as many as you want, so it's good to put on as many relevant ones as you can, because you can actually filter by classifiers. So it's just good to have them for discoverability's sake. I'm going to have just a simple list here. So we're going to say that our development status is in alpha. I'm going to say that our intended audience are developers. So this is probably some sort of tool to help with coding, like Black Rice or something like that. Then we're going to specify our programming language to be 3.10 and 3.11 compatible. And then we're going to say that the topic it's just a utility. It's something to help out. And you can be as detailed or as undetailed as you want to be with this. It's really up to you. Then we're going to have Python requires. And we're going to set this to greater than or equal to 3.10 and less than 3.11. Now less than 3.12. Because we support both Python 3.10 and Python 3.11 as we specified in our classifiers. It is important that this is accurate because pip does actually check against this. So if this is wrong, then it's not going to be installed on versions you want it to be installed on. So make sure this is correct. I used to have checks near the top. Well, I actually still do, but I don't really know if you need them because of this. But yeah, just do make sure this is correct. A lot of libraries don't actually have this less than, and that can cause compatibility problems when you then try and install it. So, say like TensorFlow or Pandas or something, if you install it on Python 3.12, it's not going to work on there at the moment. And it will try because they haven't specified this and it will break. So just keep that in mind. We're then going to have install requires, and these are your dependencies. So you can have requests as an example, and you can have like pandas greater than or equal to 2.0. So you can have requests. So this will take any version of requests, but it will only accept pandas version 2.0 or higher. And again, you can have as many of these as you want. You can pass requirements.txt files if you want. That's what I do. But as I said, I'm keeping this simple, so I'm not going to do that in this video explicitly. On top of a series of required dependencies, we can also supply a series of optional dependencies as well, using things called extras. And we can provide these using extras require. And this is a dictionary of the extra, I guess, identifier. So in this case, we'll use XL. And a list of dependencies that you need when supplying that extra. So in this case, we want to use OpenPyXL because OpenPyXL provides a mechanism of working with Excel spreadsheets. And that would be if the user were to do something like this. So we now install the Cobra package with Excel support as well. So not all Python packages are going to need this, but especially some to do with data. You know, if you want to have, well, your Excel dependencies, for example, or, you know, the ability to write to a pandas, but you don't necessarily want to install pandas by default because, you know, a lot of people probably won't use it. Then you can use it for these things. Discord.py is a kind of a channel relevant example per se. Had the voice extra, which installed extra libraries to do with voice compatibility and stuff like that. So the final few things I want to talk about are the packages one, which is just setup.tools.find packages, not fund packages. That's very different. That's more an NPM thing. And include package data, which equals true. This include package data is technically optional, though I've had problems. It defaults to false, and I've had problems if this is set as false. So I always set it as true, and it seems to fix everything. And those are kind of the two final little things. There is one more other thing that I want to talk about, but this is only really applicable if you're writing a command line interface application, and that would be the entry points. And you can define a series of entry points. I don't know what the other ones are other than console scripts, but console scripts are your CLI programs. And then you provide the command itself. So let's say, you know, just Carbra. And then you provide the function that it's going to run. So Carbra dot, and we're going to have to actually write this, I think. But say Carbra.cli :main. And then if we were to go into the Carbra, create a CLI.py, and then quickly do a main, and then print, this is the CLI. When we install, or when we pip install our package locally, if we were to run the Carbra command in the shell, then we would get this output in return, which is actually what we're going to do now. So to install your pip package locally, what you can do is pip install -e. Oh, actually, there's one more thing we need to talk about before we do that. I'm getting ahead of myself again. We need to do, well, I suppose this is an optional file, so I can sort of get away with forgetting about it, but this is the manifest.in file. And there are a few defaults when it comes to the manifest.in file, but it is always good to specify your own just in case. And we're going to do graft Carbra. So the graft is essentially include directory. So this will include everything in this directory here. And then we have our include, which is just include file. And we want to include our pyproject.toml. We also want to include our setup.py, not setup.pyproject. And then we want to global exclude star.py cod. So in certain instances, you would want to include additional files if there's like any additional configuration files, perhaps. The global exclude here is just excluding any temporary files. So the PyC, PyO, and PyD files is what this means. The PyC is your PyCache, PyO is your PyObject. PyD I actually don't know. I don't think I've ever seen a PyD file. But you see a lot of this code in like git ignores and stuff in automatically generated ones. You do tend to see this pattern a lot, so I just tend to roll with it. If anyone does know what a PyD file is, let me know, because I've always wondered and I've never bothered to look it up. But now that we've done that, we are actually going to install our library locally. So we can do that using pip install -e dot, and -e stands for editable. So it installs it kind of in place, I guess. It installs it in such a way that if you make edits to these files, then the pip installed version will react to it. If you just do pip install dot, and then if you want to make a change to any of these files, when you try to run, say, the Cabra command, it wouldn't actually pick up the changes. So make sure to type -e. And the dot, it's just your local directory. In setup, as you've provided this setup.tools.find packages, it will automatically find this one for you, because it just knows pip is not. How is pip not found? Oh, goodness. Hang on a second. Okay, so now I've restarted PyM because it was being annoying. This should work. Hey, it worked this time. Yeah, I don't really know what happened there. But as you can see, it is installing all of our stuff. It's also installing all of our dependencies as well. So it's installed pandas. It's installed... I forget which other one we had. It was request. Yeah, there we go. And if we were to do our pip install -e dot, and then this is going to have to be quotes because it's ZSH, extras, not extras, that's not what I did at all. It was XL. You can see that it will now go ahead and install OpenPyXL as well. See, OpenPyXL wasn't installed before because we didn't supply the XL extra, but now that we did, it's installed it. Woo! So now that we know how to install it locally, I'm going to show you how to build it and push it to PyPI now. We are specific. What is going on here? Why is there two? Okay, that was weird. We're specifically going to be pushing to the test PyPI. I keep saying PyPI, I just realized. It's PyPI, I got to remember that. But yeah, we're going to be pushing to the test repository because I don't really want to be putting a tutorial on the main one, but the process is exactly the same for pushing to the main one, so it's fine. So we're first going to start by doing pip install build. This might actually already be installed. It's not installed by default. Oh no, it wasn't installed. Oh, there's build 1.0.0. I think that's new. Fancy that. So we're going to do py-m build. And this will now build our environment. One thing I should have pointed out is that when you did pip install -e, it installed this cabra.egg info, which just has, you know, various. I'm not sure why it's called an egg really. Maybe snake egg or something for Python. I don't know. That seems tenuous. But yeah, this just includes a lot of stuff you can look through. And now that we've built our thing, it also has a dist with our py3-9-ne.wheel and .targetgz. Ignore the fact this is now version 0.2. I had some issues doing this before. This is actually not my first take at this bit. So it's 0.2 and it's fine. Also ignore when we install it from the repository later. It's not going to install any of our dependencies. Ignore that as well. That's the problem with the test repository, because when you install stuff in the test repository, if your requirements or if your dependencies don't update their test repositories, it's not actually going to install, it's going to error, which is a bit annoying. You won't have that problem with the main repo, but for the sake of, again, I don't want to push a test repo to the live repository particularly. So we're having to make do. This is the fun with the test. You should use the test the first time you push something up, just to make sure that everything looks right, because if you push something in the main one, then you can't actually go back and change it. You have to push another version, and that just looks weird. People will judge you, and if they don't, I will do it for them. So make sure we don't make that mistake. But now that we've built it, we can now push it to the repository. And to do that, we need a library called Twine. So we're going to do pip install Twine. There is also a way to do this using GitHub Actions, but I'm actually going to cover that in a different video. I want to do a separate video on GitHub Actions. I've been meaning to for a while, and I think that would be a good example of a workflow. So I'm going to save that for that. Also, so I'm not overcomplicating this video. So we're going to do py-m twine. And in this case, we're going to do repository test PyPI dist/star. If you're pushing to the main repository, so if you've already done it to the test one, everything looks fine, and you want to push it to the main one for real, you would omit everything highlighted completely. The default repository is the main one, so you don't need to worry about that. Press that, And then, oh, that's the wrong command. I need to do twine upload. I'm sure it used to be just twine, but maybe I was wrong about that. Now we need our username, and you don't necessarily want to put in your PyPI username and password, because you can get tokens from the admin console, and then you can pass token with, I should say dunder token as your username, and then I'm going to copy paste this token from this other window into here, and I believe it won't show. There you go, so it's there, and it's uploading, and it's there, and you get a URL, and if we go to that URL, if we open it, it should open on the screen. It does. That's good. And there we go. Our library is available on the Python package index. And here are my previous versions, here are my previous attempts that I made. So you have this release history here. You have your project links, so your homepage, your documentation, and your source. The source one probably won't work. This one will. The homepage one will work. It will take you to my actual website that you can go to. Woohoo. The other two don't, though. You don't have your license information, author information, your requires information, your maintainers, and you have your various classifiers that appear down here. You also have your brief description up here. So this is the, the one-line bit, and then your main README is inside this project description bit, which is pretty cool. Now I'm going to copy this command here, and I'm actually going to pip uninstall. Let's see if this works. Do it like that. There we go, that did work. And now if we paste that in here, so pip install -i, and then we're getting it from the test repository, we should be able to collect it. And as you can see, it's not installing our requirements because I took them out because of conflicts, but we actually managed to install our library through test PyPI. And if I were to do our command, this is the CLI. It all works. And that is everything you need to know about creating a package on the Python package index. If you like this video, make sure to leave a like to let me know, and maybe subscribe if you want to see more videos like this. If you have any questions or comments, make sure to leave them down below. I read every single one, so your feedback is greatly appreciated. If you want to support this channel monetarily, you can do so by becoming a patron or a member. £1 a month on either, and you can be in the screen like these people. And I'll see you in the next video for probably a rundown of GitHub Actions. Again, I've been meaning to do it for some time, but I never got around to it. So it'd be good to do that now. I've done this, I can then show you how to kind of advance even further in your PyPI journey. So I'll see you for that.